So what I'm going to do so that we can best make use of our time, we'll be talking about querying data using SQL Server 2012 and 2014. I have SQL Server 2012 installed on my Windows Server 2012 box inside of a virtual machine. Okay, so I just added the customers data. I'm going to do select star from customers invoices. And here it lists me customer ID of 1 and customer name is ABC Corp. I can add the customer based on the customer's schema and specifying the table that I want to reference. This schema helps me a great deal in organizing the way things are. Now the select syntax is rather simple. Let me get it from a real table. Right in here on the left-hand side, I have a person table right over here, and it has many columns, as you can see right here. I can specify what I want to look at by doing, and I'm going to specify a line here. I'm going to do edit, tools, options, and in general I can do general text editor and general line numbers. Okay, you see this line numbers right here? I like that because when I click OK, I'm able to see the line numbers of what I am typing. This way, when I want to reference what I'm saying, you can reference and take a look at the line numbers instead of me having to say, look here, look here. Okay, so right here on line 11 right now, I can say select person dot. This is the name of the table, person dot person. And I'm going to select person dot last name, comma, person dot first name, comma, person dot title from person dot person. Then I can highlight what I want to execute, and I can either press either I can press Alt X or I can hit this execute button, just like that, and the result comes right here, as you can see. So I have to specify the select statement, which means I want to retrieve data. I want to show the last name column. I want to show the first name column. I want to show the title column from this table, person.person. Basically what I'm saying is from this schema and this table. Oops. Separated by a period. Before the schema, if I wanted to, I could do AdventureWorks, not accounting, AdventureWorks, like so. AdventureWorks.person, .person. Now what that does, this is the name of the database. This is the name of the schema. This is the name of the schema within this database, and then this is the name of the table within this schema. And as you can see, the person schema has many tables underneath it. Person phone, phone number, type, state, province, and the list goes on. Product, product category, product inventory, product photo, and so on. If I want to sort this data, I can simply say order by person.first name. And what that will do is it will sort the entries by first name column. Right here, look. A's are first, bunch of errands here. See it? And then A's, and then you get the drift. And then AD and AD. The list goes on because it's a pretty big number. Right? I can, as I do this, I can also very simply filter data as well. So I can say, let me copy this since I don't have to worry about typing it again. I can copy this and I can say where. Now I want to filter. Person dot last name equals, in single quotes, I can say con, like that. And then I'm still ordering by the first name. And execute that. There is Aaron Khan, one with Mr. and one without. And I can go further. And I can say, and person dot title is not null. Isn't that cool? And let me take that order by out because I don't want it anymore. Highlight this. And now it just gives me one name. Why? Because I said I don't want any null values in the title. Null, what is the difference between double and single quote? Aha. So if a name was like O'Connor, I would need double quote. Right? Otherwise, you always want to use single quote. For passwords, for example, for any kind of string comparison, you want to use single quote. Unless there is a single quote as part of the text that you're manipulating. The only time you don't use quotes is when you have a numeric value that you're dealing with. So, if I had something like this, let me copy this text right here. And right in here, I'm going to get rid of that. And I'm going to say where person, and right here, person.person. One of the values, one of the columns is a business entity ID. See that right there? So I'm going to look for business entity ID right there. And I'm going to get rid of this. And I'm going to run that. So there's a business entity ID. See that? Now if I was doing a comparison trying to pull data for that, I would do this. I just did a copy. I would do this. I would say where person dot business entity ID is less than 300. Less than or equal to 300. I'm going to ignore this whole con business. And so there's my last name, first name, title from AdventureWorks 2012 person.person where, I didn't complete this, where person.business entity ID is less than or equal to 300. You notice the little ellipsis, the little red squiggly here? It tells me that there's a problem here, and there is. The problem is I didn't complete the syntax. This is the where clause. So now I'm just going to select this piece and run it. And now I've got I'm listing the last name and first name and title. I am not listing the business entity ID. So I'm going to do person business entity ID. Okay. Person business entity ID. Period, not comma. Okay. Now it is a very good idea, for example, when I do a dot, to use the IntelliSense. You can use down arrow to use the IntelliSense. Try not to type it yourself because it's prone to errors when you do that. So I'm going to highlight this, run this, and now I've got the business entity ID. See it? And it seems as if the business entity ID is the same thing as the results ID. See that? In this case, it's just listing it in. This is just a coincidence, all right? Business entity ID is what you want to go off of. So if I wanted to exclude all of the titles that weren't none or nulls, I could say and person.title is not null. And highlight that, run it. Now I have removed all of the null titles, right? And then I could keep on going. I could say and person title equals ms dot. How about that? Only want the Ms. title, just like that. Or I could say and not, and use the logical operator and not. It reads very similar to English. So this means and not means wherever the person title is not ms dollar or ms dot. Let's use some other things that I can show you here. I can also use aliases. Okay. I can also use aliases. So, for example, you see right here where I've got AdventureWorks person.person. It's a long name, isn't it? Right? Maybe I don't want to display that. I don't want to display that long name. Let me get rid of that. I don't want to display that long name. I want to alias this whole thing. And the way I do that is I say, let me put this from in a whole separate line. Put this over here. And I can say as maybe PPL. How about that? Really shorten it. Now what I can do is I can do this. See all those curly lines? It says, I don't know what that is. I just do people. PPL, that's my alias. So instead of typing in person dot, I just type in people dot, PPL dot. That is my alias for that whole table structure. So instead of person, I just replace it with PPL, and everything works the way it's supposed to, just like so. PPL, PPL. There we go. And I run this, and it runs, the same way. All I did is I took this whole thing, and I aliased it as PPL. Right? I can not only can I alias table names, I can also alias column names. Right? I can also alias column names. So I could say business entity ID. I can say as ID. I could actually not even. I could just do single quote ID like that. And you see where it says business entity ID up here in the column name. When I run this, after I highlight it, notice up here now it just says ID. I have aliased the column name. Right? I don't want it to say last name. Maybe I want it to say L name. Maybe I want it to say F name. Right? Maybe I want this to say salutation. Okay? So maybe I want all that. Highlight this, and now look at it. ID, L name, F name, salutation. This can be helpful when you're trying to construct reports. And nothing says that I have to have the whole PPL inside of it. I could just label it as P. And then I could just say P dot, like so. P dot, P dot, P dot. So it doesn't have to be, multiple letters or anything. It just has to be unique to the syntax. And run this. It just runs the same exact way as the other did. So that is a way to get. Now instead of typing an ID like this, I could have just done this. I could have just said ID like that. And this will achieve the same result. So if I don't want it in quotes, if I don't like that red thing, I could just as easily do this. And I will get the same result. The same result. Go over here, run this. So what happens if I change this to say ID instead of business entity ID? Notice what it did. It said, hey, I don't know what you're talking about, right? I have aliased it for the purposes of my syntax, my display, but in this case, that doesn't mean that it understands what that ID is. What, can I do this to it? Will that work? Nope, because it doesn't know what that is. Can I just do ID like so? Nope. So just keep in mind that ID is nothing more in this particular instance than display. However, the P right over here is truly aliasing this entire naming syntax, if you will, for the table and the database. Okay. Now let's see something else here. I can also concatenate or join strings together. Okay. I can join strings together. So I could do this. I could say, for example, select last name plus comma, like so, plus first name as name from person.person. Okay. When I highlight this, here's the last name and first name concatenated the way I wanted it to. Now here's the thing. There are a few things. Oh, so AdventureWorks 2012 is a database name. Yes, you got it. AdventureWorks is a database name. Person is a schema. And person is a table inside of the person schema. You got it. You can't just use from person. Sure you can. If I just said from person, it won't know what to go to. And it's not really a matter like this. See it? It doesn't know what that is. Because the name of the table is inside of the schema. Okay? So even if you had aliased it, this is a proper way. Even if you had aliased it, you really want to specify the full structure. So here's the thing. If you were working for me, or you created or constructed a SQL query, and your SQL query looked like this, I would be really angry. This is a really poorly written query because it's not complete in its form. I would really rather see this. Comma, like that, as maybe full name, like so, from person.person. What I would rather see is this. This is what I would like to see. Because it's complete. Yes, I know, it gives the same result as this. But this is complete. The name of the object is not person. The name of the object is person inside of the person schema. I can have other tables named person inside of different schemas. I can have customers.person. That would be inside of the customer schema, making it unique to it. So if I started to do and I do person ID int, and then person name bar chart. That. Okay, so this is done now. You see I've got customers person. I go back up here now. I refresh the table. And now I've got customers invoices, customers person. So if you just reference the table as person, it wouldn't know what to go to. See it? Uppercase, lowercase doesn't matter. So you want to be very careful about this whole syntactical thing, if you will. Very critical that you use proper syntax for the right reasons. Okay, the next thing that I want to show you is the way case statements work, which I think you will also really like. Okay. I will show you case statements Let me show you something first and where you would use them. I'll go over here, and let me do a select statement. I'm going to do select p dot first name, p dot last name, p dot person type from AdventureWorks person as p. Okay, now take a look at, maybe I do a select, yeah, why? Look at this person type right here. See it? EM, 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 and then I go further down. It changes to SP. I go further down, it's SC, and so on. And you don't know what those mean. If I wanted to list out all of the unique, I can do select distinct person type from AdventureWorks person.person. What this will do is it will list the unique person types. Select distinct, unique person type column. Only list the unique entries in the person type column from this database, this schema, and then this table within the schema. So it listed me these person types, but I don't know what they mean. And they're not going to make any sense to the person reading that query either. So I'm going to create what's called a case statement so that the person that reads this query, it'll make more sense to them what the query says. So let's do this. I'm going to say select first name, last name, and then I'm going to do case person type. Come on. Come on. Case person type. When the person type is SC, then I want you to list store contact. When the person type is IN, then I want you to list individual customer. When the person type is SP, then I want you to say salesperson. When the person type is EM, then I want you to list employee. When the person type is VC, then I want you to list vendor contact. When the person type is GC, then I want you to list general contact. If it's none of those things, then I want you to list unknown person type. And I want you to end as type of contact. Now this will become the column header. Okay? This will become the column header. And then I'm going to say from AdventureWorks person. Highlight this whole thing. And look now. See it? Employee. And notice it says type of contact on top. That's a column name. Go down in this list. Salesperson. See it? SPs are salesperson. SCs are sales contacts. Yeah. EMs are employees. Okay? So what I did here is I used a case statement right here to break down person type. What it's going to do is it's going to display first name and last name as it is. And then when it comes to the person type column, it's going to look, SQL Server will look and see if the person type says SC, and it will display this. If the person type says IN, it will display this. If the person type says SP, it will display this, and so on. And instead of saying person type, it labels the column type of contact, which is what it did. If you notice right here, that's the label, type of contact. Okay. So hopefully that was easy to understand in a very simple case statement kind of way. Right? So I want to show you something else that's interesting that I think you're going to find very useful. Let me see. Go down over here. I'm going to do, and go up here, I'm going to do select, login ID, come on, login ID, comma, job title, comma, from human resources dot employee, where job title like manager. So basically what I'm having you do here is I want you to give me the login ID and the title of the person whenever the job title has the word manager in it. The percent manager percent basically means that you don't care what comes before manager and you don't care what comes after manager. As long as the word manager is in it, I want to know the job. I want to know the login ID of the person. So there it is. There are all the managers listed. Okay, that's an example of doing a text search. Yeah. Let me show you another way we can do this. That's the like clause, by the way. The like clause is very, very resource intensive. You don't want to use the like clause against production level, very high read-write enterprise systems. You want to be very careful because it is very resource intensive. But as you can see, it works. I can also do this. I can say select, first name, comma, login ID, comma, job title, next line, from person.person, where first name like underscore ARY. Now underscore means you don't care what the first letter is. Oops. Is it not login ID? Yeah, it is. Oh, that's human resources employee. It would help if let me get rid of this. Wrong table. And highlight that. Okay, now look over here. It is displaying every first name where it doesn't care what the first letter is as long as the last three letters are ARY. So it's Mary and Gary. See it in the list? Mary and Gary are listed. Okay. Another way to do what's called a text-based searching, and that is using a very simple wildcard. Okay. I can also do this. Instead of doing an underscore, I could say G or M, like that. Right. Notice I get the same result, But now it's looking specifically for G and M. Now these queries from a production standpoint are very resource intensive. So you want to be careful about that. And I can also do this, like where the name starts with Gary. Starts with, not Gary, starts with G. Now this syntax right here, oops, why did I do that? A-R-Y. Okay. Now it says this parentheses means optionally starts with a G and A-R-Y. Now what that's going to do is it represents a single character that I want to exclude while I'm doing the search. So when I look further down, notice it displays me all Marys. I want to exclude the G's when I'm searching for ARY. If I exclude the M's, I get all Garys. All right. So that is the example of that's an example of a very simple text-based searching. Okay. The next thing that I want to do is I want to show you something interesting that I think you may or may not be familiar with. Okay. And are you familiar with, or have you ever heard of Json, which is basically, let me pull it up so that you guys can see what I'm talking about. Okay, so this is, as you can see, it's JavaScript object notation, JSON. Okay, you can query files based on the JSON syntax. You're familiar with JSON, aren't you, Chad? Kind of? Maybe? You can use JSON inside of a query as well. So, and I want to show you how that is done. And what I want to do first is I want to put a couple of tables together. I'm able to join two tables together via a common value. So I can say select p.name, pr.product review ID, pr.comments from production.product p, that's my first alias. And then what I'm going to do is I'm going to do what's called a right outer join, production product review as PR, and I'm going to join it on the product ID equals the production review, product review, product ID. There we go. Highlight this, run it, and here is my result. Okay. I only want to display the items that match. I want to display the names and the product review ID and the comments where the product ID matches the product ID inside of product review and product. Okay, so I am joining two tables together because product review ID and product comments only exists in the product review. And the name of the product only exists in the product. So I want to display the name as well as the comments. That's why I had to join the tables together. You cannot join tables together unless you understand how the tables are related together. Okay? You can't join tables together unless you understand how tables are related together. So you are also, I want to show you something else here. If I do what is called a full outer join, like so, that means I want everything from both tables, whether they match or not. See it? Where the product review ID and comments don't exist, that means that for this product, I don't have a review or a comment because there's nothing matching. See how many things don't match in this case? Right? And a few things that do here, for example, is something that does. See it? So this is where I got a match. If I do a full outer join, it tries to match product review with product and tries to match product with product review. Here's another one. Right? So if I do a left outer join, left and right means, and the left table is the one that is on the left side of the on. Include all of the rows. Include all of the rows from the from the left table. That's the left outer join. Include all of the rows from the left table, whether they match or don't match on the right table. So basically, give me all of the names, whether they match the product review or not, whether they have a product review or not. When I do a right outer join, in this instance, now I'm telling it that I want you to list me everything from the right table, but only the ones that match on the left. This is the right table. This is the left table. And the way I know that is because right after the from clause is the right table. Right after the right outer join clause, silly me. Right after the from clause is the left table, and right after the right outer join clause is the right table. Okay. Left of the right outer join, right of the right outer join. Keep that in mind. Okay. So joining tables is very important, but you would have to do it for a little while before you, not only do it for a little while, you have to understand the table structure before you're able to construct a proper group. So let me show you something else here. I'm going to show you how you can group things together. I'm going to do select city, comma, count, it's a reserved keyword, as totals from person.address, group by city. Now what this is going to do is going to tell me, here you can see, in Cheltenham there are 55 customers. In Kingsport there's 1. In Suresnes there's 31, and so on. It just gave me totals, okay, based on, in addresses, I've got 55 addresses in this city. I've got 97 addresses in this city. I've got 84 addresses in this city, and so on. That's doing what's called a group by. Okay. That's doing what's called a group by clause. All right. Now, if I try to include, let's say, address line 1, it's going to give me an error. It's going to tell me that address line 1 is not valid. Okay? Address line 1 is not valid because it is not contained in either an aggregate, contained in either an aggregate or the group by clause. Okay? Count is an aggregate. City is in the group by clause. Aggregate means I'm compiling them, right? I'm adding up all of the cities and then I'm counting and grouping by the city so that I get the result that says how many addresses are in a given city. This makes perfect sense. When I add address line 1, I'm asking to add a level of detail that it cannot add. How am I supposed to group and then still give you details? So, to accomplish what I'm trying to do, I'd have to do this. I would have to say address line 1, comma, and then right over here, I would have to group it by city and then address line 1. Right? And then I highlight this and I run it, and now it says, okay. Now notice I've got, for example, in one place, Beaubernard, Paris, I've got 2 addresses. I've got 2 address lines with that. In Paris. Now in St. Denis, I've got 1 address. See, many of these become 1 addresses. 2 and 1 and 2, because I added a level of detail. Then I could say, having count greater than 1. Now when I do this, I'm basically telling it only give me those lines, those aggregates, where I have more than 1 line or 1 entry for that address. So now I can see that list. When you use the group by clause, you have to use the having clause. Having allows you to filter grouped statements. So that's the way to do group by. All right. To give you an idea, a very simple idea on how group by works. There's also something interesting that you can see that I want to show you. Now, if I run this query right here, let me show you here. If I run select star, well, I'm going to do select, I'm going to do select star from person.address, and I highlight this and I run it. Returns me a lot of stuff, right? What if I do this? What if I want to do select top 20 rows, everything from person.address? It's only going to return me the 20 rows. I only want to return 20 rows from person.address. I can do fun things with this, when I'm doing calculations and such, right? I can do fun things with this. So watch this. I'm going to do select top 10 with ties, tax rate from sales tax rate, order by tax rate in descending order. Oh, come on. Okay. Now what this is going to do is, it's going to tell me the highest tax rates, the top 10 highest tax rates. Okay. So I'm using the order by clause to change the returned records by looking for the highest tax rates in the sales tax rate table. The order by has to be used in this case because I want to control the order. When I do descending, I get the highest tax rates first. When I do select top 10, of course, I get the top 10 tax rates based on the reverse order here of the highest tax rates first. Because I'm doing a descending means I get the highest tax rates first. So that way, using the order by clause and the top clause, I can determine which tax rates are higher. So that is a very small example of top option. This is the top option. So I want to show you something else as well. Let me do, for example, I'm going to do a select, count, basically count everything from human resources schema employee table. Count. So this tells me that I have 290 rows in the employee table. I want to say, okay, well, I want to expand that. I'm going to say I want to select count, but I want to count distinct, I don't know how to spell distinct, distinct job title. That's unique job title as number of titles from human resources employee. Okay. Now what it's going to do is it's going to count the unique job titles out of the 290 jobs or employees. We have 67 that have a unique job title. All right. Now I can also do this. I can say that select average vacation hours as average vacation hours from human resources dot employee. So what this is going to do is just going to average out vacation hours. As you can imagine, that's the name of the column. Average AVG vacation hours is going to be the title of the column. Human resources is the schema. Employee is the table in that schema. So when I run this, it's going to say 50. Average vacation hours among everyone has been 50, which means that there have been people that have more or less, and I don't have to use average. I can also use max. Okay, somebody had 99 vacation hours. And then I can also use min, which is minimum vacation hours. So if there are people in there that have used no vacation time. Okay, so that's average, max, and min. I can also do this. I can also just say add up all the vacation hours. Okay, 14,678. 14,678. I can also do this. I can say select min vacation hours, min vacay, like that. And then I can do some vacation hours as tot vacay. Right. Then I can do max vacation hours as max vacay. And I can do average vacation hours as average vacay. All right. And then I can do some sick leave hours as some total sick leave. Okay. And then I can say max hire date. Who did I hire last hire date? Who did I hire the most recently? Human resources employee. Highlight this whole thing and run it. Of course, I have something wrong. Some vacation hours, average vacation. Oh, I don't have a comma. Let's try that again. Highlight. Oh, two froms. Can't be a good thing. No good. Highlight that. Run it. Look. Minimum vacation 0. Total vacation 14,678. Max vacation 99. Average vacation 50. Total sick time 13,139. And last hire date, I hired someone in July of 07. Okay. So way to get. Now these right here are known as aggregates. You understand why. I'm aggregating a bunch of things. No kidding. Okay. So these are known as aggregates.